Section 2 is the Voronoi diagram, which is going to be brand new to every single person here, and I would guarantee with like a 95% certainty there will be at least one question on your IB exam centered around using a Voronoi diagram. Okay, so that is something that if you're trying to do well in the IB exam, it's fairly easy, but you need to know what it is and how to use it. It's not super difficult. They're easy points to capture, but you have to have seen it before and be aware of it. Okay? So the quick little geometry review, there's some parts of a circle. This is just basic vocab rather than defining what these things are in words. I think the picture says 1,000 words there and just kind of like reminds you what these features are on a circle, whatever. If we have a pizza with an area of 120 square centimeters, and we cut it into 8 equal pieces as shown, what is the area of one slice? Guys, how much is the whole pizza?
8 slices. Oh, higher square.
120, right? And so how much of it do we care about?
Just 1/8 of that.
1/8 of it. Done, right? I don't know, crunch some numbers together if you want to. I think I heard Marin whisper that it's 15. I'll believe that. Part B says, what's the area of 3 slices? Oh my gosh, guys, like 3 times. Yeah. So difficult, right? The idea here is that like everything is just proportional, right? If everything is split equally, we just divide it equally. If I know the total area, I just divide that total area. Easy peasy. In this next example, we have like a sprinkler, and it has like a 150-degree, rotation on it. We're looking for the area of grass that is watered. So again, we're talking about like this shaded area. How much? What percentage of the circle or ratio of the circle is that shaded area? How much is a full circle in degrees? 360. How much is this area in degrees? Okay, so it's 1/5. Come on in, Jamie. Out of 360, and then pi r squared. Hi.
Hi. So I got to the study arm, and my retake test was supposed to be like today. But I got this from student admissions, and I didn't know I had to do this, but I think that they want me to do this like for the lucky day, like for the student ambassador like thing and the criteria. So now I don't know if I'm supposed to go to this or if I'm supposed to not do it and take my test. But I don't know
if you want to take your test at a different date, if that's what you're asking because you think this is important, then you need to do that. I understand. Yeah. And that's okay.
So can I redo the form, or do you want me to put a new date for the test?
Have you started it?
No, I haven't started the test yet.
Yeah, just tell Mr. Emmerich what's going on, that you're going to do it on Tuesday or whatever next week, and that's fine.
Okay, thank you.
No problem. Tia, this one's for you. No, it's fine. It's just like a counselor appointment or something. I don't think that's a uh-oh, right? That's a, oh, I know what it is. There you go. Is everybody good with how we got this one set up? Right? And you could grind this through, but who gives a, like we got a calculator. You can type into calculator. We don't care about that. The next one, it says, it's about a plane flying. So like the dotted line is the path of the plane. Because, when a plane flies, the planet's a circle or a sphere. So it's not really taking a straight line path. It's taking a curved path. Or else it like runs into the side of the planet. So it says calculate the distance along the Earth's surface the plane must travel. So it's basically just looking for this distance. Instead of dealing with a area this time, we're dealing with the perimeter or circumference, if it's a circle, usually we use the word circumference, but perimeter's not wrong. So we're going to do the same thing, right? Like what proportion of the perimeter is this covered, or proportion of the circumference? So we know the circumference in total is 2 pi r, and it tells us the radius of the Earth is that. And then how much of what proportion of the whole circle is being covered there? Perfect. So Brooks recognizes that half a circle is 180. So this is going to just be 180 minus 47.5 minus 25 over 360, and that's good enough for us, right? That's the setup. You guys can grind it on your calculator if you needed to. In part B, it says, but what if the plane is flying a constant elevation of 10 kilometers above the ground? Well, we're just like tacking on like an extra 10 kilometers there, right? What's that changing? Just the radius, right? Just adding 10 to the radius. So the only thing that's going to change is the radius, and then everything else stayed the same. Does everybody feel okay there? Any questions on dealing with these circles? The key is if you want part of a circle, as long as the part of the circle is like at the center, like the angle's formed at the center of the circle, it's just proportional to how much of the, how much of the angle is covered of 360. That's the idea. All right. The next thing we're going to talk about are these Voronoi diagrams. That's what your handout is covering, and I gave you the handout because, who's got the time or the inclination to try to replicate one of these pictures into your notes? Ain't nobody got time for that. It's nice to be able to kind of draw on the sheet of paper as we kind of go through things and look at what's going on and how to use the thing. So I wanted to give you guys all something that you can follow along on. It's not an assignment, it's not due, it's not homework, it's just for you to practice on while we're kind of talking about it. So I want to explain kind of what we're looking at here first, the application end, and then we'll talk about how we construct this. So there's oftentimes in the real world where you have a bunch of locations that service a specific area, right? Whether it's what cell phone tower is your cell phone pinging to, depending on where you're at, or what police station is covering a crime that occurs in a certain location, or what hospital do you get taken to if there's an emergency call at a certain location. And the idea here is you'd want to divide the area up so that based on your location, you're going to the closest hospital or the closest police station or the closest cell phone tower, right? So one way you can do that, assigning of who covers, what area, is to construct one of these Voronoi diagrams. So if we're looking at, say, the location E, this would be our hospital or police station or cell phone tower or whatever. Anything that happens inside this region, E is the closest location. So any crime that's committed, police station E is the one that would deal with it. Any ambulance call inside that area, hospital E is the one that would receive that ambulance. Any person making a cell phone call in this area, tower E is the one that the cell phone would ping to. Is everybody okay with that idea? So the way this kind of a diagram is constructed is we construct these boundary lines between the nearest other sites. So again, if we're looking at site E, I would look at the boundary, to construct the boundary line between E and O, I'm going to find the midpoint between E and O. and then construct the perpendicular bisector to it. And that's going to give me that boundary line between E and O. And then I would do the same thing between E and K. Again, perpendicular midpoint, perpendicular bisector. That'll give me that boundary line. Everybody's okay with that? And if you remember back from geometry, maybe you do, maybe you don't. If we have a perpendicular bisector, any point on that perpendicular bisector is like equidistant to either end of the segment your bisector is perpendicular to, right? Do you guys remember that? So what that would mean is that on E, any point on this line between E and K is the same distance from E as it is to K, right? Would be that those distances are the same. And likewise, then, if we're at a vertex, that means that the distance from that vertex to O, E, and K, all the same. Does that feel okay with everybody on kind of how to read and interpret this thing? It's not, again, it's not like crazy complicated. The idea is really simple. You're just talking about like simple algebra 1 lines here. We're just talking about perpendicular bisectors. Everybody feel okay as to what we're looking at? All right. So let's do some examples now on using one of these things to answer some questions. So it says identify the site closest to the point 30, 20. So if I do that, 30, 20 is like here. So what site is closest to that? A, because it's inside the boundaries for site A. Is everybody okay there? Now ideally this, you can see maybe that it looks like this was, there's a graph paper background to this. It didn't transfer real well on the scan. On an IB exam, there would be a grid in there for you to where you wouldn't have to guesstimate quite so much. Brooks?
It's a dumb question, but if it's already in its grid, it's automatically telling you that that's the closest point.
If it's inside the boundaries for that site, you don't even have to do any kind of measurement or any calculation.
Cool.
That is by definition of how the Vroni diagram is constructed. It says, part B says, give the coordinates of a vertex equidistant to 4 sites. So there we're going to need a intersection of these lines, these boundary lines, where 4 boundary lines meet. Right? That's all we need to look for. So if I look, starting at the top, that's only 3, that's 3, that's 3, that's 3, 3, 3, 3, 3. Look real close. It's 3 here and then 3 there. 3, 3, 3, 3. Aha! There it is. 4 boundary lines meeting at one point. That's what we want. So it looks like that's the point 20, 5 maybe. Is everybody okay with what I did to look for that? Again, if you know what you're looking at, really simple, right? Like not a difficult question at all. It says estimate the coordinates of a point equidistant to A, E, and K. Okay. So to do that, I'm going to look at the regions for A. I'm going to look at the regions the region for E. So now it's down, so I'm between these two, right? And then I'm going to look at the region for K. And that's narrows it down to this guy right here, right? Did you guys see that? That's the only one that intersects all 3 regions. It looks like that's the point 20, 26 or something. Again, ideally, on the IB exam, you'd be given something where the grid is clearer to read than the one that I have here. Everybody's good? Again, very simple if you know what you're looking at, right? Like I did no calculation for this. I did nothing. I just looked at the picture and had to go on a little hunt, but a pretty easy hunt. It says, explain why the diagram cannot give us a point equidistant to C, F, I, and L. So if I were to do that, I'm going to look at the regions for C, I, and already I can stop, right? Because what do you notice about C and I? Well, they're not adjacent, right? But if I keep going, let's see, we have F and then L. So we could say the three regions for sites C, F, I, L do not all share a common vertex or something like that. Everybody was okay with that idea? And even if it was C, F, and L, right? No common vertex there between them. So like, again, still wouldn't work. Even though they're all neighboring each other, they're all touching, they don't share a vertex in common. All right, part E is probably the most challenging one. It says the point A comma A is equidistant to sites J, F, and N. Find the value of A. So what kind of points look like A comma A? Well, like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, etc., right? So basically what we're doing is we're just looking for things on this line that's like at a 45-degree angle. And if I want something equidistant between J and N, I want something on that boundary. So I'm just looking for the intersection for that line, like y equals x, and the boundary between J and N. That to me looks like the 40 comma 40. Does everybody feel okay with what I did there? Again, like if you know what you're looking at and like make the observation that, hey, like I can just draw that line like y equals x, which contains all the things that are A comma A, and just look for the intersection of that and the line between J and N. It's like, piece of cake, dude. Took me all of like 10 seconds to do it if I know what I'm looking at. The last question is the only one which requires any kind of calculation. And it says it wants us to find the equation of the edge between sites E and K and write that answer in the form y equals mx plus b. So it wants the equation for that line, right? So to write the equation for a line, I need a point and a slope. So my point is going to be the midpoint between E and K, because I know that boundary has to be the perpendicular bisector of the segment EK. And then the slope needs to be the negative reciprocal of the slope from E to K. Again, because I know that boundary line is the perpendicular, so the slope has to be a negative reciprocal. Everybody feel good there? All right, so to calculate a midpoint, it's just the average of the x coordinates and then the average of the y coordinates. So that is 1023. Everybody's okay there? And the slope for EK then is just going to be y2 minus y1 over x2 minus x1. So my equation going to be y minus y1 equals the negative reciprocal of the slope for EK times x minus x1. And then I just can rearrange. I think that'd do her. So you guys feel okay there? So again, anytime you're asking for an equation for one of these boundary lines, it's a perpendicular bisector. You need the midpoint, and that's the slope of the midpoint between the two sites, and then the slope of the two sites. The midpoint is your point. The negative reciprocal of the slope is your slope for your boundary line. Everybody's okay? All right. Let's go to the next one. This would be the worst case scenario for an IB exam, where this would be like the most time-consuming thing they could possibly ask you is to construct your own Voronoi diagram for sites. I don't think they would ask you to do that. I think at best they would say, here's a partially completed diagram, and we're going to add in one more site and ask you to complete, to finish it. But we should go through how we do this. Everybody's okay? So if I look at this, I'm going to need a boundary between A and C, between A and B, between B and C, and between C and D and B and D. Everybody's okay there? I don't need a boundary between A and D because B and C come before that. Is everybody okay there? So let's do A to C first. Now, do I really need to do anything to construct a perpendicular bisector to the segment AC? I don't really need to do any calculation here, right? Why not? Because AC is a horizontal line, right? What's perpendicular to a horizontal line? A vertical line, right? And what's going to be the middle of that horizontal line between 2 and 6? 4. So I mean, like, don't overthink it, right? What's the other super easy one to construct? Yeah, why is B to C super easy? Because it's vertical. So what's halfway in between 6 and 0? 3. And perpendicular to a vertical line is a horizontal line. Everybody's okay there? It's okay that I didn't do any calculation for this. We just observed and used basic Algebra 1 geometry knowledge to draw those two guys in. All right, let's save our effort for the more complicated ones. For between A to B, I need the midpoint there from A to B. So that's going to be the average of 2 and 6, and then the average of 0 and 6. So 4, 3. And then the slope for AB Does everybody feel okay with what I've done? Now, I'm not going to bother writing the equation for a line because it doesn't ask me for the equations. It asks me to draw the picture. And I don't need the equation for the line to draw the line. So I'm just going to save myself some time. So I'm going to start by plotting the point 4, 3. Everybody okay there? And I'm going to go rise over run. So I'm going to go 2 units up and then 3 units to the left because of the negative sign. Is everybody okay with that? Or you could go 2 down and 3 right. That's fine also. Everybody's okay there? Okay, and then I need between B and D and C and D are my last 2 then, right? So I get my slope between B and D is negative 1/3. So the perpendicular is just going to be positive 3. So again, I'll plot the point 10.5 comma 4.5. And then I'm just going to go 3 up and 1 unit to the right. So 1, 2, 3, and then 1 to the right. Okay, there. And then my last one is C to D. So that's 6 plus 15 over 2, and 3 plus 0 over 2. And I got another slope of 3 there. You guys feel okay? So I'll plot 10.5, 1.5. And then I'm just going to go 3 units up and 1 unit over. 1, 2, 3. And then 1. It's like that. Okay. Now what we need to do is kind of eliminate the unnecessary boundaries, right? Because these lines we've extended forever in both directions, but they don't really exist in both directions because we're really only talking about boundaries. So this, let's start with A to C. So this first vertical line between A and C really only goes to here, right? Because after that, it intersects another boundary. So this part above can go away. Actually, let's use like a color. Everybody feel good? Okay, and then if I look from B to C, so that's going to be this division. And then if I look from A to B, I just need this part of it. And if I look from B to D, and we have C to, why did I? Do I have made a mistake there? What did I do? I mean, it doesn't look, something looks up. Oh, thank you. So that's a positive 9. So that should be a negative 3 there. So that line is in the wrong spot. That feels much better. All right, so I'm going to go 1 left and then 3 up. I don't want to go 3 down because it's like off my grid. So 1, and then 1, 2, 3. That seems so much better. Okay. Thank you for following along. You should have hollered at me sooner. That's okay. The fact that you had it when I was like, oh, what's wrong here? That's it. That's good enough. So thank you. All right. Between C and D, that is this line here. And so the only part we need is that part from C to D, or boundary C to D. And the last one is the boundary from B to D. So we just need that part. And there's my completed Voronoi diagram. Again, more than likely what you're going to want to do is draw the whole line and then erase the stuff that you don't need. This is the worst case scenario in that it's just time consuming. Yes. But my supposition is that you wouldn't have to do this for an entire diagram. They'd have you just like add in 1 point that might require like an extra 2 boundaries or something, which would be a heck of a lot less time consuming than what we just did where we had to do the whole diagram. Okay. Moving on, it says use the map of rainfall measurements in figure 5.5 to estimate the rainfall at coordinate 6, 4. Okay, well, I'm just going to plot 6, 4, which looks like here, which means we're in region P. So it looks like our rainfall I'd expect to be 0.63. Nothing more to it than that, right? Super easy. Okay. The last question, I think, says find the coordinates of the center and radius of the largest empty circle in the Voronoi diagram. So largest empty circle means that that circle contains no sites. So it shouldn't contain the points A, B, C, or D. What are the obvious choices for my centers? Should be the intersections of my boundary lines. So it looks like I would choose 4, 3, or I might want 10, 3. Everybody's okay there? So the biggest center biggest circle I could have that starts at 4, 3 would have the radius so that it can't contain sites A, B, or C, right? Now I know, because it's a Voronoi diagram, that those are all the same distance, so I don't need to calculate all 3 of them. One will do. So let's just use A. So we have the square root of 4 minus 2 squared plus 3 minus 0 squared. So that's oh my goodness, Mr. Kulik, that's 2, 0. Woo! 4 minus 2 squared, that's 2 plus 3 minus 0, that's 9. So that's square root 13. Everybody's okay there? And I'm going to do the same thing now for the other possible circle. I can already tell that this is certainly going to be the bigger of the two, but it wants the radius, so I have to find it. Again, because it's a Voronoi diagram, I know that all those distances are equal. So I'm just going to calculate this one. And I don't even need to do a calculation to find that, right? Because it's a horizontal line, I can just count. So I'm going 10.3 to 15.3, that radius is just 5, right? We just went 5 units to the right. Now you could do the distance formula if you wanted, it's still going to come out to be 5. But that's my bigger circle, because the radius is bigger. Questions about using these Voronoi diagrams? Again, the calculations we're doing here are super easy. This is like Algebra 1 / geometry type calculations. It's just an application where if you haven't seen this before and you don't know what you're looking at, what the heck am I going to do with this thing? You just have to have seen it and understand what it is you're looking at. But this should be relatively easy points on the IB exam. Any questions on these Voronoi diagrams? Okay. So again, the last 2 assignments that we haven't scored in yet are the Chapter 4 review and the Chapter 5 review. The Chapter 5 review has Voronoi diagrams in it that you'll have to solve problems involving, so that's good practice. That's it. Next week, we meet twice. We're just going to talk about IB exam and IB exam preparation, probably work on some of these papers in groups and kind of present some answers. The emphasis I would place for you guys is really making sure that you understand how to use your graphing calculator here, because I would say it's, if you just can, only stuff you can't do any math by hand, all you can do is stuff on the calculator, but you're a master of the calculator, you can probably get at least a 5. Without having to do, it's like my algebra stinks, I don't know how to do I can't do anything by hand, all I can do is use my calculator. You can get a 5 at least on these exams, just by knowing, like if you know what to do with your calculator and how to use it, you're good. You're good. Okay? So that's mostly what I'm going to focus on the review days, like making sure we know, if it's this kind of a question, how do I use my calculator to do this? Like, how do I set up this t-test or this chi-squared test? Or, like, how do I run these statistic outputs so that I don't have to do it by hand? Or like, how do I do this algebra thing by hand? Or how do I do this summation with the calculator instead of having to do it by hand or use a formula? So that's going to be really my point of emphasis. I'm going to stay away from the content for the most part. I mean, we can talk about that if there's questions there, but for the most part, I want to talk about, like, how do I read the question, know what to do, and then what's the most effective way, especially utilizing my calculator, to answer those kinds of questions. Does that make sense to you guys? So it's going to be real practical, test-centric Like, what can I do to make sure I can perform well here with the minimal amount of effort, so that when I get to something like, I don't know what the heck to do with this, you have time to muddle that over because you've banked a bunch of time because you did everything the fast way before that. You know what I mean? Okay. Well, I'm done talking. That's it for today. You survived. Congratulations. The content for IB Math SL A&I is completed. You did it. Yes. That's it. I'm done. Work on your section or your chapter 4 and 5 reviews. That's the Sunday problem set. I think let's do this real quick. I'm going to mark those in as zeros right now so you can see with the drops and everything before the weekend. I already did that for you guys. Oh, never mind then. Good. You can see exactly what would happen if you did nothing, but looks like you did that. I did that already. The other thing I would remind you guys is that there is a survey at the very bottom of your minor ordained page in the announcement section that contains a link to the end of the semester survey to let me know whether you want to take a doubled high test score or do a test retake. Especially if you're planning on doing a retake, you want to get that figured out way sooner than later so that we don't have to cram that down your throat in the last second. It gives everybody a chance to see what happened before the end of the semester. But if you're just like, I'm just doing the double, like fill that stuff out right now and send it in. We've done all the tests, let me know. Fill out the survey. Today was my tentative deadline, so please try to get that completed here soon if you know. Some people emailed me about wanting to wait for this or that or a reason, I have a makeup pending or whatever, and that's fine. But all the rest of you schlubbos have done everything you're going to do, like fill out your survey, man. Okie doke. All right, I'm done.